Okay, Wildcats, today we're looking at Thursday, February 14th, rational function inverses on page 55. If you would, update your table of contents. Okay, now your table of contents are updated. Now let's take a look at our notes. All right, rational function inverses on page 55. 4 ways to find the inverse, f inverse of x. Number 1, graph, reflect over the y equals x line. 2, table, switch x and y. 3, algebraic, switch x and y, and resolve for y. And 4, composition of functions. When fog, fg of x equals x, and golf, g f of x equals x, when the result of fog and golf is x, and f of x and g of x are inverses. A little note, domain and range will switch, and the asymptotes will switch in inverses. Okay, if you would, update your notes. Now your notes are updated, let's take a look at the examples. All right, so I've kind of drawn some lines to help keep some of the notes and examples organized a little bit. So if you want to do that, please do so now. While you're doing that, let me adjust the lighting a little bit. Hopefully that's good. All right, graph the inverse f of x. Okay, so I'm going to do the function in purple. Okay, and I'll do the inverse in yellow. Okay, so we have x and f of x. All right, so let's use our first value, x negative 1. Okay, so we're going to substitute negative 1 in for x, so that's 1 divided by negative 1 plus 2. Well, that equals 1, and let's use x as 1. So 1 divided by 1 plus 2 equals 3. So let's go ahead and graph those points. So negative 1, 1, and 1, 1, 2, 3. Now, for asymptotes, we see here that if we substitute x equals 0, 1 divided by 0 will be undefined. So at x equals 0, that's one of our asymptotes. And we see here that the graph shifted up 2, so that means our asymptote is at y equals 2. Okay, so there's the function. Now, of all the things to graph, this is probably my least favorite because now we have to graph the inverse, and you're going to have 2 more asymptotes and 2 more graphs, so the graph's going to look really messy, but it is mathematically correct. Okay, so for the inverse, real simple, we switch the x and y. So then this is 1, 3, and this is negative 1, 1. Now, our asymptotes for the function were, for the function, this is x equals 0, so for f of x, and y equals 2. Okay? So before we graph these points, we need to switch the asymptotes. So x equals 2 and y equals 0. Okay? So our new asymptotes are y equals 0, and x equals 2. Okay, at this point, we're going to graph our points. Okay, so now these are points, not directions, so we actually graph the actual points. So 1, negative 1, Now you have to be careful because it's based on this asymptote, so our curve is here. Okay, and then 3, 1. Okay, so just so you know, like there's so many points I couldn't figure out where the center of. So I knew there's 8 tick marks, so I went 8, 7, 6, 5, 4, 3, 2, 1, 0. So I know my center is here. So I go 3 to the right, 1, 2, 3, 1. And there you go. All right. So we already talked about asymptotes. So let's do for f of x and for f inverse of x. So for f of x, your asymptotes were x equals 0 and y equals 2. And for the inverse is x equals 2, y equals 0. All right, so let's look at example 2. All right, so again, we're going to do f of x in purple. And we're going to do the inverse in yellow. All right. Now, I'm going to use the first x value, -3. So then that's 1 divided by -3 plus 2 minus 3. And that equals -4. And then my next value is -1. So 1 divided by -1 plus 2 minus 3 equals -2. Now in the last example, I put the examples on the top, but I didn't realize that I already left space for the asymptotes here. So let's do the asymptotes here. So f of x and f inverse of x. All right. So here for the x asymptote, well, -2 plus 2 is 0, so 1 divided by 0 is undefined. So our asymptote is x equals -2. And you see here the graph shifted down, or down 3, so it's the y asymptote is y equals -3. So let's go ahead and graph those now. So x equals -2. And y equals -3. Okay, so now let's graph the points. So -3, 4, so -3, so -1, 2, 3, 1, 2, 3. All right, and let me losing track of the center. This is the center. Let me put it like just a circle there so I can keep track of the center. It gets hard when you have all the asymptotes and curves and things like that. So -1, 2, 3, -1, 2, 3, 4. There's your curve. Okay, and our point is -1, -2. So here's our curve. Okay. Now for the inverse, we switch x and y. So -4, -2, -3, -1. And we also need to switch the asymptote. So x equals -3, y equals -2. So let's go ahead and graph those. So x equals negative 3. Gets really messy. It's one of my least favorite things to do. And y equals negative 2. All right. Now let's graph the points. So negative 4, negative 3. Negative 1, 2, 3, 4. Negative 1, 2, 3. Getting really, really messy. All right. And then another point is negative 2, negative 1. So negative 2, negative 1. Again, just messy, very messy mathematics. All right. So you would finish up example 1, example 2. All right, now let's take a look at example 3. All right, so first off, change all the f of x's to y. And to solve, we switch the x and y. So x equals 1 divided by y minus 2 plus 3. All right, next is subtract 3. So x minus 3 equals 1 divided by y minus 2. And we probably want to put those in parentheses. Divide by 1. And we need to probably add some lines here. All right, so now we cross multiply, so then that's x minus 3 times y minus 2 equals 1. Now remember, we're solving for y, so we're going to divide both sides by x minus 3, so you get y minus 2 equals 1 divided by x minus 3. Add 2 to both sides, so y equals 1 divided by x minus 3 plus 2. All right, so go ahead and finish up example 3. Now let's take a look at example 4. Okay, so example 4. Switch x and y, so x equals negative, I'm going to put the negative with the 1, divided by 2y. I'm going to put a 1 here, cross multiply, so then it's 2y times x equals negative 1. Now remember, we're solving for y, so we're going to divide x by both sides. And probably bring that work up here. So 2y equals negative 1 divided by x. And then you're going to divide both sides by 2. So y equals negative 1 divided by 2x. Now, I didn't show several steps in this part, so if you need me to show some of the pieces, ask me during the teacher-led station, and I'll show you those steps. All right, go ahead and finish up example 4. All right, example 5. Okay, so again, switch x and y. So x equals 1 divided by y plus 4. Okay, we're going to subtract 4 from both sides. So x minus 4 equals 1 divided by y. And let's go and add some lines to here. All right, so now we're going to cross multiply. Probably want to put that in parentheses. So then you get y times x minus 4 equals 1. Divide both sides by x minus 4. So y equals 1 divided by x minus 4. All right, so finish up example 5. All right, let's take a look at example 6. So again, switch x and y. So x equals negative, and put the negative with the 1, divided by 2y plus 4. I'm going to go ahead and divide that by 1. And then we want to cross multiply. So that's 2. I'm going to go ahead and put the 2 and the x together. So 2x times y plus 4 equals negative 1. Now you want to divide 2x by both sides. So you get y plus 4 equals negative 1 divided by 2x. Subtract 4 from both sides. So y equals negative 1 divided by 2x minus 4. Okay, so if you would, finish up your examples, start working on your assignment, and have a wonderful Wildcat day.